computer science professor at University of Illinois at Urbana-Champaign. She is also a director of Coordinated Science Laboratory at the College of Engineering. And Klara, over the year, has done a lot of influential work at the intersection between real-time multimedia resource management in large-scale distributed systems. More recently, she has done work in things which we are also working in the context of the RISE Lab, in the real-time security, and of course multimedia immersive video. Today, I should say, over the year she got a lot. She wrote 2 multimedia books, so she's an authority when it comes. She's the authority when it comes to multimedia, and she receives a large number of awards, and including she's IEEE Fellow, ACM Fellow, and also a member of German National Academy of Sciences. So today she's going to talk about some of her most recent and exciting research. So without further ado,
thank you.
Let's welcome Klara.
Thank you, Ian. It's my great pleasure to talk about some challenges and opportunities with multi-camera systems. I a little bit modified the title since I am going to talk about a lot of systems issues. So what I do want to do at a much higher level is to talk about some of these multi-camera systems like the teleimmersive system, then some of these live broadcast systems and Video 360 systems to motivate actually some of these problems that are coming and are related to the multi-camera systems. And then we will talk about challenges and opportunities, and then I conclude. I will try to watch the time. So I identified sort of 3 type of multi-camera systems that I think are coming, are here, and in some way what you are going to see within the next 10 minutes is, I think, the state of where we are with some of these multi-camera systems, and basically what are some of the next generation challenges for these systems. So the teleimmersive systems are actually systems that you can imagine you have a site, you have a room that is full of sort of cameras, and you are taking different views of the particular person, if it's a dancer, if it is a patient, or if it is a trainer, and you basically can look at this particular person from 360 sort of degrees. These cameras are 3D Kinect type of cameras, and then actually what you can do is have multiple sites. And for me as a systems networking researcher, what's interesting is that you basically have to stream the data towards each other to actually render them all together, so that then all 3 people from all 3 different sites are rendered in the same virtual space. And you can see here these examples. You can have geographically distributed patients, doctors that basically meet in the virtual space. Everybody sees the same virtual 360 space, but you can basically then move in the virtual space and help. This is actually Professor Baichi doing Tai Chi. This was her work, and then jointly actually we have done some work with dancers between Illinois and Berkeley. But of course you can also think about having distributed players that are playing actually games and then immerse themselves into the shared space to actually work and play together. So just to sort of give you a feel for where currently we are, this is actually a video that has been taken here at Berkeley. We have actually brought Illinois dancer and the Berkeley dancer, and have been putting them into 2 distributed spaces. And then you will basically see how they get rendered together. And so these dancers actually could develop a totally new set of choreographies as they have been dancing together, but each in a different sort of space. And there were multiple cameras, two sort of cameras, taking bottom, taking the upper levels, and rendering them all together. So basically, traffic would go between those two spaces to actually get them so that they can actually see the same thing. So both Renata and Lisa from Berkeley, actually the both dancers, have been then seeing the same virtual space and could dance. So a lot of really fun problems of synchronization, of bandwidth management between these two sites had been important to actually make this work. And we have actually, this is actually local area network, but we have also done experiments between Berkeley and Illinois. And of course, very interesting problem was end-to-end delay for us. Another example I want to show you, this is currently coming from Microsoft, how they are actually using Kinect, 3D Kinect
Hi, I'm Phil
cameras.
Chow, a principal researcher. We've been looking at how to use color plus depth cameras, such as the Microsoft Kinect, for immersive communication. Let's take a look at some of the benefits that Kinect can provide for remote collaboration around an electronic whiteboard. Of course, Kinect can offer audio and visual communication, and here you see my remote collaborator, Zheng Yu, in a video window next to our shared writing surface. But Kinect can be used for a lot more. Its depth information can be used to remove the background around Zheng Yu's head, giving him some privacy, and it can also be used to frame him automatically, keeping him in frame wherever he moves. More importantly, Kinect can be used to provide a level of immersion that has not been possible before. Here we see what we call a 2.5D visualization, in which Zheng Yu can actually reach out of his video window to write on the shared writing surface. This is important because I get to see where he is writing, where his focus of attention is, where he is about to write. To understand why that's important to me, we're going to play a little game. So in this game, you see a set of 20 symbols. They come in pairs. 2 red squares, 2 blue squares, and so forth. I'm going to erase one of them, and Zheng Yu has to erase the corresponding one.
So I think this gives you an idea of this teleimmersive, again, collaboration, and researchers have been looking at these multi-camera systems in these immersive spaces, very much sort of the next generation of Skype, next generation of teleconferencing, as I would see that. Second large category of multi-camera systems is in the live broadcasting. Here currently a huge amount of investment is happening, particularly from the sports industry, where you will have very powerful, basically HDTV type of cameras, pennant, zoom and tilt and so on. And you actually place these particular cameras around the large stadium, and you are then taking images, videos from different sites of the particular players, and you are streaming them. Many of these cameras are 2D cameras, but very high quality at 60 frames per second, and are basically giving directors that are then narrating and moderating the particular TV program for live broadcast to everybody. And so what you are starting to see actually from these multi-camera systems is that you can see a soccer, for example, not only the main player playing sort of field, but also different camera views. And of course, on mobile devices, you can now watch different camera views, and also either on mobile devices or on large-scale screens. And the nice thing actually is that you get a very different perspective from these different cameras. These particular cameras, all of these views and streams are being managed by NBC, CBS, ABC, right? There is somewhere a director that is basically managing and telling where you currently want to see the streams. I am waiting when all of these streams get released, and you at home can do actually personalized viewing, and you can decide actually what you want to watch. And so I want to sort of show you again what is currently sort of happening. You have here, sort of a real-time game, and what is possible at this point that you are watching one particular main camera view that the director decided, but then actually some of the other cameras you can start to see actually in these smaller windows. And of course you can then switch between the different sort of some particular window you could actually bring to the foreground and another gets into the background. You can also actually see that when you have multi-camera around these particular sports events in mobile devices, you could actually use your touch to change the views and watch the particular game in different views. So these are technologies that are currently coming and are sort of available, but as I said, some of them are very much structured and being controlled by directors of these larger, like ESPN or some of these other companies, or you basically can download these particular, all these sort of streams and then view those data. The third category of multi-camera systems, it's a little bit different types of system. And what is currently happening is the Video 360. This particular camera is actually a multi-lens type of camera. So here currently in the top, you have basically a camera that has multiple sort of views. And you can put it on a stick and then basically walk with it. And what the camera does, it actually records and then hopefully sort of streams data from different types of views. So it's basically from the inside to the out you are watching. And so on the YouTube, actually, we will see a lot of videos where you can currently sort of see things from different types of views. And what is also happening is that these particular views you can then put together, and you can use so-called regular sort of type of stitching capabilities, and like the maps, so when you want to flatten them and basically start to stitch these different views so that you can actually then get this kind of sort of top, sort of funny type of shape. And I will show you a video how in the VR or in the sort of animated world, this kind of stitching and viewing actually is much more prevalent. But I think as these multi-lens cameras are coming, we are going to also see videos in this particular space. One really major important issue to keep in mind with respect to Video 360 is how people are going to be watching this particular video. And there are now multiple modes of navigation and viewing this kind of Video 360. So one, of course, is with the head-mounted displays. And you basically put it on and are basically, as you are moving with your head, then the particular head direction should actually also show, I want to see now this particular view. When I move the particular head this way, that particular view I want to see. Another possibility is that you have this kind of spheric Video 360, and then actually these videos will have here top sort of some kind of controller, and with your mouse you can actually sort of move around the Video 360 and see different views. Or more and more you are starting to see these mobile devices. You can basically download some of these Video 360 and then use actually as you are moving with your the accelerometer basically is used to actually determine I want to go down or up or left or right, and then basically it corresponds to the particular views. So I want to just show you how a sort of example of a Video 360 might look like. This is currently from Game of Thrones. And you can see basically this is actually all the sort of stitched together, again, 360 spherical video, but then it gets stitched, sort of, you can display it on a 2D. You can then start to look at from the up, from the down, from the left, from the right, and basically explore your video as you are going. find, since we are doing some research in this space, and I think big HCI issue is going to be cybersecurity. I do get sick when I watch this a little bit longer. That's something I think our HCI colleagues will have to sort of work on.
Is that an official name, cyber sickness?
That's currently what's current, yeah, cyber sickness. Yeah, that's the.
This was a totally simulated environment.
This is simulated environment.
Any angle you want, but for the sports things, they have only a finite.
There is no video 360 yet, right? That's basically in the live broadcasting at this point is only separate windows. These are 2D sort of videos, and that's currently the space. They didn't yet come. Those are basically separate cameras, so you can actually get here. This is actually from multi-lens single camera. Right, so that's a little bit of a difference, and I'm excited sort of what will happen in this space. So I want to sort of push further that these particular 3 different systems are going to see much more application in healthcare, virtual opera, multiplayer games, social events. And from my point of view as a systems designer is that these different advanced applications that are going to be using multi-camera systems, there are going to be some very interesting challenges and issues that I want to also further elaborate. The requirements are going to be, for example, from the virtual opera, and I will give you sort of, hopefully we get time to talk about it. You could have sort of virtual performers, and you want to actually then have many people are watching that, and you need flexible sort of scalability, or in virtual sort of social events. On the other hand, we will have multi-camera systems where in healthcare, for example, you go home and maybe you get packed with a little coffer, multiple sort of single cameras, or use some of your own home cameras. But there, of course, are going to be low resource computing environments. In education, if you have multi-camera sort of systems. So one of the really important issues with these multi-camera systems then really comes in this tension and trade-offs between actually user satisfaction, how good is the particular HDTV video, the content complexity, how many video streams actually views I can watch, and resource requirements, how much CPU, how much network bandwidth basically can I use. So you basically know that if you increase the content complexity, for example, in terms of number of views, number of cameras, currently actually, for example, for the video 360, you can have maybe 4 lenses and 4 streams coming to stitch together, but there are also 8 of those lenses, and then in these live broadcasting, you can have large amount of cameras around the stadium, so you can increase the content complexity, but of course if your resource availability is low, then your user satisfaction goes down. On the other hand, if you currently do want to have a user satisfaction, that's your primary goal, and your resource requirement is low, then actually the content complexity might need to go down so that you can actually satisfy the user, at least at that particular space. So the ultimate motivation in these multi-camera systems is that what we currently see is still very limited. In the teleimmersion, you have, I showed this sort of 2 immersive people. In the live broadcasting, you will basically see these 2D cameras that are being streamed and live broadcasted, or in the video 360, you are actually going to see people are recording, stitching, storing. There is no live streaming. And then basically you are using YouTube to basically are watching that. So there is still very limited scale, and then also some of these applications do assume a lot of network and computing resources. And one of the reasons is that there is basically this tension. And so if we want to have advanced applications with these multi-camera systems and provide flexible scalability, low computing environment, and much more complex multi-camera systems, we do need to sort of solve it. And so I do want to talk a little bit about challenges and status. So in order to talk about challenges for these multi-camera systems, we do need to look at how these particular multi-streams, multi-cameras get delivered. There are usually three important stages. It's the capturing stage, it's the dissemination stage, and it's the receiving stage. And we will be looking at each of those particular stages. So in the capturing stage, you are talking about multimedia. You are talking multi-modal space, multiple 3D, or you are looking at this particular multi-lens type of camera with other type of sensors that either it's health sensors or mobile phones and so on. And you are dealing with huge amount of data. So the challenge here in this particular space is big data and real-time challenge, because you do want to, we are looking at real-time teleconferencing in the immersive space, or live broadcasting, or I would like to see video 360 basically streaming to people. So we are looking at, for example, in some of these 3D cameras, you are even looking at small sizes of videos, lower temporal resolutions, and you are very, very quickly coming to 300 megabits per second uncompressed. Of course, when you go to 640 by 480 or even by HDTV, now some of these cameras can do, you are really going above. And so you do need real-time 3D compression for this particular case if we want to do real-time communication. Another really big issue for this whole capturing, that the amount of bandwidth that is required is just absolutely not feasible for households where you do have restrictions in bandwidth. So that's one sort of very, very important aspect to sort of consider. In the dissemination phase, the challenges are, you are at this point sort of in the real-time space, collaborating in real time, that's all sort of merged, fused together into these virtual spaces, or to your screen, it has to come to some degree in a synchronized fashion, right, on your big TV. And you can actually push it even further. Just imagine that you have many, many different sites, and each of these sites actually is currently multi-camera, and you are exchanging all of these streams to actually render them and to create basically some sort of joint Skype session with respect to video to actually work on that. We have done some sort of connectivity of this kind of multi-camera systems in joint sort of project with Professor Baichi here. Actually, we started this work 2004 when I was here on sabbatical. And we also worked sort of on multicasting. One of the really important results for us from this point of view was you saw the immersive people talking to each other, two of them, the two dancers. We have been successful to actually run multi-camera. Multi-camera means 4 cameras and with up to 8 cameras in one site to run maximum 4 sites. And the reason was basically multiple, as I will talk about it. One is bandwidth. Basically, you just don't have enough bandwidth. Another very major issue for this particular exchanges of immersive teleconferencing with multi-camera systems is real time. You basically want communication to have a meaningful communication between at least 100 to 120 millisecond. For voice, of course, it's something like 80 millisecond. And with all the amount of sort of data, if you want to sort of send all of the streams, all of the cameras, or if you will render it, it's just really, very challenging. And it's very interesting when we run the experiments with the dancers, what the delay would do to them, right? They would wait what did the person do, and how do I follow? I mean, these delays are changing your behavior, how you communicate in this kind of advanced teleconferencing system. So the maximum group size is truly bounded, at least for us in these delay constraints. So one of the things that we then said, okay, in the immersive space, what's the size of these multi-camera sites and communicating would be actually 4, but then how about if we can multicast it and actually have non-immersive people watching some of these multiple players as they currently are in their 360 sort of bubbles and then rendered virtual together. And so we started to look at actually peer-to-peer live broadcast possibility. And there, of course, you start to have very interesting set of problems, because now, basically, you are starting to have the real-time communication between the players that are currently virtually, for example, 2 dancers exchanging their content, and they are actually representing the virtual opera or virtual dance. But then, as a viewer, I want to actually now decide to actually watch this particular content. Maybe I want to look at Renata, I want to look at Lisa, different. And so you can start to see actually here on this particular graph that as you start to look at the live broadcasting, on the x-axis, we have here number of viewers. So if I go towards 1,000 viewers, and on the y-axis, I have the amount of bandwidth. And you can see basically as the number of viewers come, even if I start to do multicast, peer-to-peer, there actually the latency is less critical, because you are just viewing particular sort of multi-stream type of content, but still the bandwidth basically becomes a major challenge to do that. And so the maximum around sort of 12,000 megabits per second, sort of going really to gigabits type, it's basically we managed around 1,000 users in simulations. So you really need a lot of bandwidth if you want to provide multiple views to these various viewers as they are watching this virtual content. So we also sort of then experimented with, how about if we are just delivering certain particular views so we started to differentiate the camera streams by sort of through the shooting angles. And we realized, particularly in this space, if you do want to do large scale broadcasting of multiple streams and with different goals, you need much more sophisticated differentiation of these streams as they are currently being streamed from this virtual space of dancers. So on the receiving side, you are currently at the space of your displays. You have mobile displays, you have large-scale displays, and there basically you either have the synchronous receiving when you have this teleconferencing immersive space or the synchronous live broadcasting, or you can actually have a sort of the asynchronous approach in receiving, where, as I mentioned, particularly in the video 360 currently, the approach is because the stitching and the preparation of the video 360 is so complex that basically it's an offline operation. We basically are storing it in the cloud, and then basically from the cloud, from the YouTube, you are basically streaming that. So here the major challenges are real-time challenge. Again, how do you do 3D compression in order to fight some of the devices that don't have as much bandwidth availability? And there has been some progress in the 3D compression in terms of compressing point clouds or in the mesh-based. Actually, the mesh-based compression is currently also being considered by various standard committees. But there are common insufficiencies. One really doesn't still do 3D compression among streams. For example, you are doing sort of compression on a single stream, but there is quite a bit of correlation between these multi-camera streams. And what you see currently, that whatever is out there, for example, one technique you can think about it, the 3D streams will have a RGB plus depth. People will use H.264 on the RGB and then ZLIP, for example, or other lossless compression on the depth information. But whatever is there currently, the compression ratio is not yet good. So it's a storage impact in terms of challenge and real-time challenge. And then the big challenge becomes, how do you render all the data, these multiple streams on the displays? The most solutions at this point are not looking at your power usage, are not looking at that you have maybe low bandwidth device. They really assume a lot of resources as these multi-camera contents are being delivered. So there is truly lack of adaptiveness on resource fluctuation and problems with these resources, and also no adaptive sort of computation distribution. There is some movement in this whole adaptive rendering where people are starting sort of to look at, for example, in 2D streams, standard called DASH, Dynamic Adaptive Streaming over HTTP, where actually you can tell your server, this is currently what my capability is in terms of display, in terms of temporal resolution, and you basically get sort of choose from certain media presentation descriptions, and then basically the cloud will send only that particular capability to your, in terms of video stream. But that actually is for a single stream that is being explored. There is currently some research going on for the Video 360 and Dash, where you have basically or stitched the video together and compressed by 264, since this is a 2D video, and then basically streamed over to your devices. But we do need Dash for, or this kind of delivery systems, an adaptive rendering for Dash for multi-camera content. And we do need to actually, when we do adaptive rendering, we need to better understand users, their interest, usage of the head-mounted displays. So for example, one of the biggest challenges in this, for example, Video 360 is the motion to photon delay, right? Between when I have a headphone, head-mounted display, and I turn this way, I do expect that particular view to be displayed. So there is basically 2 to 8 milliseconds. People are citing different delays. And the question is, how do you deliver that particular view? You have to deliver all of them, but does your device have those particular capabilities? Now, because it's more non-real time, people offload the whole Video 360, and then actually you are sort of able to continue. But of course, some of these head-mounted displays or the mobile devices might not have that kind of capability. So people are now looking at predictive techniques, how to predict where am I going to be looking at. Understanding TV viewing patterns, and so on. So I want to just summarize some of these challenges. Content bitrate capacity of these regular households are problematic in dissemination. You do have support of multi-view, but under limited bandwidth, and then the receiving, you need to have efficient storage, adaptive rendering. So I want to talk about some opportunities of research actually that I see in this space. And I want to talk at least one, maybe two of these examples. So to deal with this amount of bandwidth requirements for these multi-camera streams, and deal with also the tension between the user satisfaction, resource constraint, and content complexity, I believe that these multi-camera systems must utilize semantic information coming from the application users during capturing, during dissemination, receiving, to maximize the system's efficiency. So in some way, what we have been exploring, and I'm seeing it more and more in these multimodal environments, that people basically are starting to look at semantic information that comes from environment, from activities that people are doing, and from users in terms of user roles. And so let me a little bit elaborate what are some of these semantic information that I feel if we give them properly, so if we currently represent them properly and give them to the systems can actually much better deal with the tension between user satisfaction, resource constraint, and the content complexity. So in the environment semantics, what I feel is that we do need to consider what is currently the room. What is, am I currently at home? I heard today, actually, I talked to various researchers in terms of healthcare, right? When we send patients home with some of these multi-camera sort of systems, or they actually use some of these cameras, we do need to know if it's a mobile or dedicated facility, what kind of networking. And this is already sort of starting to happen, what kind of computation, I/O devices. And it definitely helps then the underlying system to adapt the content complexity, avoid, if we do know what the environment is, avoid wasting of unnecessary resources. And the reason I'm sort of talking about this is because I think the systems have been before very much implemented application agnostic. And I feel that we do need to start to at least have a better understanding what's happening at the application level. Activities, you saw actually in these multi-camera systems, if it is players, live broadcasting, if it is teleimmersion, even in the video 360, it is important to understand if this is currently a video activity, it's lecturing, gaming, physical exercise, because then actually you can start to actually use motion vectors if it is currently, what kind of activity, fine motoric movement and so on. What's the pace of the motion? What's the region of interest where you currently have to focus actually your resources to get? And it helps then the system to do adaptive compression, quality enhancement, and provisioning of bandwidth provision. And then, of course, the user semantics. It is very important if you know that the viewer, for example, is just the audience, non-immersive, where the performers are currently in a sort of performing among each other. If there's a doctor and patient type of relationship. And it basically helps you then to construct, for example, dissemination, if you know basically what the user semantics is. Or you could allocate uneven resources and handle basically as the systems come on, for example, in the peer-to-peer system. So I feel that there is sort of some kind of middle platform that I think also Ian and many other researchers are looking at, and we as well. But I think that this particular platform does need to start to have some better interfacing to this semantic information and help to resolve this particular conflict and the trade-offs. So I want to talk very briefly about at least one example, if not both of those. So activity-aware quality of experience, bitrate. So this is currently the tension between the user satisfaction, which is represented through usually quality of experience, and then the resources, and that's the bitrate. Usually, if you want very high user satisfaction, you basically have to have a very high speed in terms of frame rate, you have to have a large resolution, And that is a lot of sort of video views, and that's usually infeasible, as I already mentioned. However, if you do take activity semantics into account, for example, I have here the lecture, the reading, exercise, gaming, you can then basically start to see, we have done some preliminary experiments, is on the x-axis you have the temporal resolution degradation. So you go basically from 30 frames per second down to sort of maybe 10 or 5 frames per second. And on the y-axis, actually, you have a dissatisfaction, proportional of noticed pattern that basically noticed. And you can see, actually, that if I currently do lecture and reading, even if I go currently and send less frames, less temporal resolution, the user doesn't see that particular dissatisfaction. On the other hand, if I do exercise and then I have a low resolution, then basically you can start to see on the green or the blue line basically immediately dissatisfaction. So you can utilize, if you have this particular information, and send less bits and help in that particular space. And so when you start to sort of plot it, the lower sort of the motion and the activity is, then you are basically getting better mean of score, which is the measure of the quality of experience, but you can basically run with 2 or 4 or even 6 frames per second. On the other hand, with the exercises, you have to really have a larger frame rate and larger bit rate, but it can actually very often sort of save you up to 35% bit rate in this particular differentiation. And the thing is that the user still can be actually quite happy and you can have a high satisfaction. So the second example I want to sort of show with respect to the challenge and then opportunity is on this virtual seat. I do want to credit this to Professor Henry Fuchs. So here is currently the idea. So the idea is that you have actually a virtual stage. All of these little circles are actually the sites of performance. Think about Renata and Lisa dancing together, right? And they basically are in a separate space and they are creating the choreography. And from that virtual space, we are then live broadcasting to other viewers. And so one of the things that we actually wanted to do is say, okay, let's have so-called virtual seats around that virtual stage. So I basically could reserve this particular space, and then actually from this particular view, I just get those particular views that I can see. And as I mentioned, it comes from Professor Fuchs, because at one of these conferences, he said, you know, Klara, I would like to not come to the conference, but reserve that particular seat. And there would be my avatar, and I can actually, through the avatar, see what is currently happening. So he talked about sort of this kind of, so that is we have sort of modified, but it's truly that you are now basically reserving. So instead of getting all of the views through all of the cameras, you basically are going to just get whatever you are seeing with your particular seat. And that, of course, having this kind of fixed position as the performer performs, then it decreases the amount of bandwidth. But you might be actually very happy because you are currently seeing. And of course, you could actually switch the seat and go somewhere else and then basically get to another view. So in this particular case, this approach is then much, much more manageable because then different people actually have the different views, and you can then basically create this kind of hubs where this is basically one view. This is a set of audiences that are viewing, for example, anything around this particular view, and then another sort of view, another person is seeing that. And this is sort of much more manageable in terms of bandwidth and also latency as the particular distribution sort of happens. And so 2 things I want to sort of comment that came about. So one is basically having this kind of semantic decisions of what is currently the virtual seat. But the other really interesting thing is you can actually then differentiate. So these are currently streams that are for me, and then the rest are not sort of interesting to me. But with all of these multi-camera systems, you can also start to differentiate roles. So for example, I am currently having a children's play. My son, my daughter are currently playing a game, are playing a theater, virtual theater, and you are currently watching it. Well, for you as a parent, your child is really important. So you can actually start to also differentiate the role, the player, and then actually maybe those particular video streams get delivered to you much better quality than, for example, somebody else's child, right? So, you know, school play, you can do user defined, and you can map it into the priorities so that an underlying system can actually do much better scheduling and so on. So there are many, many different sort of role-based priorities, and again, through this priority, but you have to then have this middle platform to actually map this particular semantic information to the parameters that the systems can do. And you know, these particular systems, for example, in this virtual amphitheater, you can create sort of these distribution graphs, forest construction algorithms through publish, subscribe type of sort of system. Then there's a forest planning, and you can the performers are publishing, broker is basically managing, getting this particular whole distribution graph, and then you have subscribers that are viewers that want to see that particular virtual view. And the results definitely support this. This is currently much less sort of intensive on the bandwidth, and we are basically also seeing much less rejection rates than, for example, previous approaches like the 4D telecast, where there was multiple trees basically trying to deliver everybody's views, but at some point basically was not enough bandwidth, you had to sort of reject them. And the same thing actually is in terms of the application acceptance ratio. Again, we had a much better information quality. So I want to conclude, since I'm coming to the end of my talk, that the semantic information, if we can sort of start to get hold of them in a better way and move them to the systems, I believe that we can solve this tension between user satisfaction, the resource constraints, and the content complexity. Other sort of type of environments that I actually think will be coming, and there are tremendous opportunities, is locality, is temperature, is spatial room environment, right? How far are these particular cameras? Activities, what am I doing currently with the head, with my hands, sort of hand gesture? What kind of level of detail do I want? If we can basically get hold of this kind of information, specifying it, I actually think the systems can deliver much better user satisfaction and quality of experience. And of course, the user roles, if we do know what kind of roles and relationships you are in, we can provide much better personalized viewing. I think that's the ultimate goal. And so overall, I think that we are going to see much more semantics aware content delivery frameworks, as well as more and more, I think we will see this semantic aware dissemination, particularly, for example, many of these real-time systems have session management capabilities, and they will be connected to some software-defined network controllers. And one other technology that is coming is edge networking. And how do we actually then work with these multi-camera systems using edge networking, using cloud and sort of real-time capabilities are all opportunities to do research in. That's about it. Thank you. Yeah, go ahead.
I have a question. So, related to the opportunities.
Hold it.
So, related to the opportunities, specifically with the semantics awareness, have you considered like leveraging things from computer vision or psychology techniques that say, well, look, when people are watching videos, they tend to focus on like faces. right? And so I can ignore having high quality backgrounds because people are probably not like focusing on the crowd, for example, in the audience of a basketball game, but they're focusing on like the players' bodies. And having those kind of, before you send out data, you're doing these kind of processing and saying, based on like prior knowledge from like the vision community, I'm going to prioritize only portions of my data stream as being high quality versus other portions being like not high quality.
So yes, and actually there is, particularly in the quality of experience area, on the user satisfaction, quite a bit of psychoanalytics going on. And that actually will be very interesting if we do understand what is currently important, what is less important, to actually sort of decouple them. But yes, the same way as the psychoacoustics is being used for compression, for example, in audio, psychoanalytics is used for video, and I would like to see that actually being done in multi-camera type of systems. But yes, that's definitely a direction to go, yeah.
How do you query the audience or the people who are watching in terms of what is important for them to see? Is it questions that are asked ahead of time, or is it based on learning their behavior over time?
Right. So because this particular system has this publish subscribe type of, so you basically do subscribe to a particular seat, right, in that space, and then actually I would envision, I mean, this is also our opportunities. We haven't, a full-fledged system doesn't exist. This is really sort of the future. That's what I wanted to present. We have some preliminary results. But I would basically assume that you would have a choice as you subscribe to the streams, that you say, not only here is a virtual stream, but I also want to watch my daughter, and this is currently the role. So whatever views are currently coming and following her, I want to get those particular views. So it's publish and subscribe, and then as the publishers are publishing and sending the data, the broker basically would differentiate through priorities, basically who gets what. Yeah, but
So I can see some applications where the multi-camera system is really great. You know, if it's a basketball game, I have a favorite player. It's the semantics. I just focus on that player. Nothing else matters. On the other hand, in the example of the, three-dimensional stage in the theater, the system makes it harder than it's really needed, because a good director will set up, say, a ballet, so it looks perfectly good from up front. When there's a symmetrical display, it is symmetrical for the center of the audience. When the four little swans are dancing, they're dancing seen from the front, and there's no better view than that. And by the time you start to make a 3D camera or a 3D stage surrounded by all of these cameras, you now have to set up a performance looks good from all sides, which is almost impossible. So in a way, you're creating a technology that then essentially has a pushback of making it much, much harder to even set up a scene that is worth seeing in that way. So I think some of these areas I can see is a lot of hype there, and
this is currently where I am, for example, very curious what the dancers or what these performers will do. There has been a revolution when cameras came and the dancers had to dance in front of the camera because they had only very limited space. Now, basically, with these whole 360, I was watching some of these dancers, how they have to be aware constantly if they basically the whole stage, not just the front where the audience is, but everything becomes my sort of space where I could be watched, right? So we will see. Currently, for us, it's the interesting system space and multi-camera sort of space. Technology makes it possible. Of course, there is going to be what really will sell, right, in terms of feasibility.
Think about movie making, right?
Right.
So people just act, and then you have the cameras, and the viewer is supposed to look which is the good direction.
Right.
Where, a good director sets it up very carefully, so you have the face in front, the right background, and all of that.
But I can see that there could be a channel, a view channel, where you basically have the director give you whatever content you want professionally. And then you have other channel, right? Almost like in the remote, where you can control the views. And will be interesting if how many, in some way, I see it on the younger people. Yeah? I mean, they are currently going to the YouTube. They want to control what they want to watch, how they want to watch it. So it will be interesting, yeah, you know.
So I imagine that one of the application of these 360 views, the cameras, it's actually to extract the geometry of the objects from the real life, and then again it's embed them or import them in a simulator. I think that Kinect is doing a little bit of that. So what is a state of the art there? Is how fast, how accurate you can do it? It's again just having multiple cameras, looking at this kind of room, and then extracting and modeling it and importing in a simulator.
That I don't know. The one sort of things that I have seen is that people are stitching the various videos. I haven't seen anything that is done real time, as they are currently recording, and as there are editors now that you can actually sort of stitch these particular different videos and then store them as this equiregular sort of type of videos. But I haven't seen in these Video 360s papers, at least at ACM Multimedia or on some of these on the YouTube, that people actually would be plugging them into other simulators. So, so I don't know. Something really interesting direction, yeah.
So one quick question related to the previous question.
Mm-hmm, go ahead.
So I'm wondering, like, I only have two eyes. I can only like watch one direction, although you can give me multiple cameras, multiple views. But in some sense, that human has some kind of limitations. Like our sensor, we don't have enough sensor to like get exposed to that many multimedia. So like, what's your interpretation of that? Is there a limitation of this, and how do we need to take into account as like multimedia researcher in designing our systems?
Yes. So one of the sort of interesting aspects I feel, that some of these other sensors, for example, in homes, could use as a contextual information to help you to decide which particular view you basically would be viewing. As you said, you have only two eyes, right? But if you need to start to sort of search through it, right, why not some of these sensors to help you? Another thing is that this is actually coming sort of to the psychoanalytics, that if you do understand your imperfections of eyes, and you know currently what is the region of interest, you can put much more resources into that because you are currently watching. So one of the possible scenarios, for example, we have been working with physiotherapy. And there actually, the doctors do want to look at these different view cameras as the patient is exercising, but they don't want to look at hours of videos. And so they actually want to see, if it's currently a physiotherapy where you are exercising on the arm, they want to see actually your particular region, right, on that. And then basically you can decide which particular view you are putting, and also even within the view, which particular region currently is showing, and that's what you stream, maybe in high performance. And you see that actually in the 2D video where you have a very sharp rectangle, and then the rest gets blurry, right? And you can start to sort of think about it in the multi-camera system as well. But yeah, I very much agree, and this is currently where, for example, psychoacoustics use some of our sort of vulnerabilities, that we don't hear weaker sounds if you have a loud channel, sound channel, and therefore you can cut bits for the weaker channels, right? You use that psychoacoustics to decrease the amount of resources you need. It's the same thing with the video, right? So I'm sure we will see much more connection to psychology and what we can and cannot do. You know this video from Gorilla? you know, where basically there is the video of, this was a Haberman, so I think was doing this experiment that you have a group of people passing a ball, and you as a viewer are asked to basically count how many times you sort of move the ball, and then in between basically the background is being changed and the gorilla is walking by, but you are focusing on the number of these. So I think those are the psychoanalytics that we will have to explore in these multi-camera systems.
Okay, that's great. Let's thank Klara again.
Thank you.